So here we're looking at the second page of that first review. So the instructions for 19 and 20 state that we want to rewrite an expanded form using the properties of logs and exponentials. So here again comes a part where we have to know our properties, both forwards and backwards, in order for us to accomplish these problems correctly. So using those properties, I want to, first off, I realize that I'm expanding this. So I know I'm going to want to write log base j as many times as possible. So I see two different variables. I know I'm going to at least want to write it twice. So that's step one. Step two is I can realize that this degree up here for both of my different variables can be rewritten with bringing that to the front. So 3 log base x, 5 log base y. And then my last step, my last property that I need to know is the product property of me saying that if I write log base j x times y, that's the same thing as me writing log base j x plus y. So you're rewriting it as, I think I said that wrong. You can write it as log xy is the same thing as writing it log x plus log y. So that's the property that we're using here in order to write it like this. So y'all did really well with that on the quiz. Not too worried about that part. I felt like y'all did pretty solid there. So here, this might be tricky because we've never really had two things in the numerator being multiplied and two things on the denominator being multiplied. So how we want to do this is with multiplication, we know that we have to use addition. With division, we know that that has to be subtraction. So we do our addition of the numerator, log base 8a, with the 3 out in front, plus log base 8x with the 4 out in front. And now everything that's written on the denominator needs to be subtracted. So I have minus 5 log base 8b minus 2 log base 8c. Now some of you, this is 100% correct. That is a good answer. Some of you like to write it like this, where the numerator is still perfectly the same, but you write the denominator like this because you like to show this multiplication as addition. So you have to put this parentheses in order to justify that that still belongs on the denominator with this subtraction sign. So in reality, these are saying the same thing. It's just two different ways to write it, and both of them are perfectly acceptable. So now for the next two questions, we want to condense them. We want to write it as one single logarithm. So here we look at this and we know that we have subtraction. So immediately we should go to, in our brain, that we know that it should be division because now we're working backwards from the previous problems. So I know that I need division here. I know since I'm condensing, I only want to write log base 3 one time. And then here I brought my degree down in front because I wanted to expand it. But now that I'm condensing, I want to take this degree, this coefficient, and move it back as a degree. So w to the 4th over g to the 6th. And that would be our final answer for that one. For 21, we see that we have two different things going on here. So again, this one might look more like this problem, where we have two things being multiplied on the numerator and something on the denominator because we see this subtraction sign and this addition sign. So we only want to write log base 3 one time. We have x and y being multiplied together in the numerator, so we see that perfectly. And then we have minus, that tells us this needs to be over something, z to the 2/5. And that's exactly what we need to do. We have to identify this negative right here and know that now we're switching properties from the product to the quotient property, and it telling us that anytime we subtract, we then need to, if we are trying to condense it, we then want to divide, show that as division. So for the graphing two, I'm only going to do these top two. The bottom two are very similar, and I feel like we've done a lot of graphing over this band, so I think that that will be good practice. The key is still up, so you can absolutely use that to check. But as far as going into deep detail, I'm only going to do the first two. So the first thing that I always love to start at is saying my home pivot point for that equation. So I know it's a log, so I know my home pivot point's at 1, 0. So next thing I can do is I can look at this and say, okay, I know my b, it needs to be written in this form, a function b x minus c plus d, and it's not because my b right now is inside that parentheses with that x. So I need to factor that out. So I have negative log negative x plus 2 plus 3. So this has more significance than you think because not only did it change the fact that we moved that b out, but it changes this sign. And when it changes that sign, this looks like I'm moving to the right 2. But in fact, since I hadn't factored that out yet, I'm actually moving to the left 2. So doing that is very crucial part of being able to solve for these graphs. And of course, always, the first thing that I would suggest you do, even before stating your pivot point, is plugging this into the calculator so you can get a good idea of where your graph looks like, of what your graph looks like. So now that we know what the reflection of both x and y, that's going to change both of these to negative and negative. So really the only one that mattered was this one right here. When we reflect over the y-axis, it changes this negative to -1. When we reflect over the x-axis, it changes this 0 to -0, which we still just note as 0. And this will always be the case. If we reflect over the x-axis in any log, it's not really going to adjust your pivot point too much. Only when you reflect over your y-axis will it show significance. So now we do our transformations. We're moving to the left 2. So left 2 and up 3. And so we get our pivot point is at -3, 3. And so we go and graph that. Next, we want to find our asymptote. We know with logs we have vertical asymptotes. And I make my argument equal to 0, so this x plus 2. So I get x equals -2 as my vertical asymptote. As always, vertical asymptote means domain restrictor, so that means that my domain has to be stopped because of this -2. So if I'm looking at the graph from the calculator, it looks something like that. So I know that it's going infinitely far to the left. There's no restrictions to the left of this point. So it can go to -infinity, but it has to stop at 2 due to that domain restriction. My range of all logs is -infinity to infinity. So that would be kind of what I'm looking for number 23. Now we move to the exponential side of it. So we are looking at what is our pivot point. After we plug it into the calculator, we know our pivot point for all exponentials is 0, 1. So here, it's the opposite of this, right? So anytime we reflect over the x-axis is when that reflection takes significance. So we know after reflecting across the x-axis that we change the y, so it's 0, -1. Next thing we have to do, our b is not factored out yet, so we need to factor that b out. We get -2 to the 3x plus 2 minus 1. So once we do that, we now have that we shift to the left 2. So we're subtracting 2 and going down 1. So we're taking away 1. And with that, we get our pivot point is at -2, -2. And that's our point right there. And with these, whenever we know that we have a horizontal asymptote because we're thinking about the inverse, we look at this term right here. So y equals -1. We should also be able to tell that by our graph, but that's just a nice easy trick to see that we use that final term over there. So we think exact opposite of here. So since my range is always -infinity to infinity for a log, for an exponential, that means my domain is -infinity to infinity. And my restriction comes from my range with my horizontal asymptote. So after I graph this, I see it looks something like this. And it goes from -infinity because it can go all the way down, and it can go as high as -1. So that would be all I need to do for this, and that's going to wrap it up for this part 2 of the video.